My dear students, in this video, I am going to find out the angle between two curves. Angle between two curves. Y equal to f1 of x is one curve and y equal to f2 of x is another curve. Y equal to f1 of x is a curve and y equal to f2 of x is another curve. These are the two curves, y1, y equal to f1 of x and y equal to f2 of x are the two curves. They intersect at the point P, x1, y1. See, they intersect at the point P, x1, y1. Angle between two curves is the acute angle between the two curves. That is, acute angle between the point of two tangents drawn at the point of contact. Angle between two curves means angle between the two tangents that can be drawn at the point of contact, point of intersection of the two curves. If the point of intersection of the two curves and the acute angle is the angle between the two curves. This is obtuse angle. This side is obtuse angle and this is acute angle. We have to find out the acute angle. The angle between the two curves is the angle between the tangents of the two curves drawn at the point of intersection of the two curves. Suppose y equal to f1 of x is one curve. So y dash dy by dx from this slope of the first curve dy by dx is m1 say. Slope of first curve. Similarly, slope of the second curve dy by dx equal to m2. See, we can say the derivative of y with respect to x for the second curve is slope of the tangent to the second curve, that is m2. Slope of the tangent to the first curve is m1. So angle between the two curves means angle between the tangents are drawn at the point of intersection of the two curves. That is acute angle. Angle between the two curves is angle between the two curves is the acute angle theta. Acute angle theta between the tangents drawn at the point of intersection of the tangents drawn at the point of intersection of the two curves. Suppose this is tangent drawn for the first curve and this is a tangent drawn for the second curve. The point of intersection of the tangent is acute angle is the required angle. It is tan theta equal to modulus of m1 minus m2 divided by 1 plus m1 into m2. This is the angle between the two curves. Modulus of m1 minus m2 by 1 plus m1 m2. m1 is the slope of tangent for the first curve. m2 is the slope of tangent for the second curve. If the two curves are parallel, remark, if the two curves are parallel, if the two curves are parallel, then the slopes are equal, m1 equal to m2. If the two curves are parallel, the slopes are equal. Okay, if the two curves are perpendicular, if the two curves are perpendicular, if the two curves are perpendicular or cut orthogonally, if the two curves cut orthogonally, then m1 into m2 equal to minus 1. This is the condition. If the two curves are parallel, then slopes are equal. If the two curves are perpendicular or cut orthogonally, their product of the slopes m1 into m2 equal to minus 1. Okay, these are the two conditions for finding the angle between the two curves, and this is the formula for angle between the two curves. This is the formula tan theta. Okay. So using this, we are going to solve the problems in the exercise. We have to find out the acute angle theta. That is the angle between the two curves. Okay. See, now we will solve the problem in your textbook given. That is, find the angle between the rectangular hyperbola. Ninth problem in the exercise 7.2. In the exercise 7.2, ninth problem. Find the angle between the rectangular hyperbola xy equal to 2. This is the rectangular hyperbola, and the parabola y square x square plus 4y. X square plus 4y equal to 0. We have to find out the angle between the rectangular hyperbola xy equal to 2 and the parabola x square plus 4y equal to 0. We have to find out the angle between these two curves. First, we have to find out the point of intersection of these two curves. We have to first find the point of intersection of the two curves. The point of intersection of the two curves is from the curve 1, y equal to 2 by x. Because xy equal to 2, from this I can get y equal to 2 by x. Y equal to 2 by x. This x, you bring it to the right hand side, it becomes in the denominator of 2. Now substitute y in the place of the equation 2. Replace y in equation 2. So from the equation 2, x square plus 4 into y is 2 by x equal to 0. X square plus 4 2s are 8 by x equal to 0. Multiply throughout by x, eliminating the denominator x, you have to multiply throughout by x. This is x cube plus 8 equal to 0 into x cube, x is 0. From this I get x cube equal to minus 8. From this x cube equal to minus 8 implies x equal to minus 2. Because minus 8 whole cube minus 2 whole cube is 8 minus 8. Therefore x cube equal to minus 8 is x equal to minus 2 into minus 2 into minus 2, that is minus 8. So x equal to minus 2. Substitute x equal to minus 2 here. You will get y value and you will get the point of intersection. Therefore, we know that y equal to 2 by x. Y equal to, in the place of x, you replace minus 2. So that is equal to 2 by minus 2, that is equal to minus 1. So y equal to minus 1, x equal to minus 2. Therefore, the point of contact is the point of contact of two tangents. Minus 2 comma minus 1. X is minus 2, y is minus 1. This is the point of contact. minus 2 comma minus 1. At that point, we have to find out the angle between the two curves. For that, first curve xy equal to 2, differentiating by product rule, product rule x into y derivative dy by dx plus y into derivative of x is 1 equal to the constant term is derivative of is 0. Therefore, dy by dx equal to minus y. So, dy by dx is minus y by x. I am differentiating the first curve. You have to find out the slope of the tangent for the first curve. X into derivative of y dy by dx plus y into derivative of x1 equal to a constant derivative 0. From that, dy by dx is minus y by x. You know y is minus 1, x is minus 2. So that's equal to minus of minus plus 1 by minus 2 is minus 1 by 2. This is slope of the tangent for the curve 1 M1. Similarly, you have to find out the slope of the tangent for the second curve, x square. So from the curve 2, x square plus 4y equal to 0. Differentiating x square is 2x plus 4 into y derivative dy by dx equal to 0. So dy by dx is, from this dy by dx is minus 2x by 4. This 2x, if you bring it to the right hand side, it is minus 2x by 4. That is equal to minus x by 2. To cancel minus x by 2, you replace x equal to minus 1, minus of minus 1, plus 1 by 2. So, tangent, slope of the tangent for the second curve is slope of the tangent for the second curve dy by dx equal to minus x by 2. You know minus x is minus 1, sorry, minus 2. X is minus 2. So x value is minus 2 by 2. Minus 2 by 2. So minus plus 2 by 2, that is equal to 1. This is M2. Slope of the tangent for the second curve is 1. Slope of the tangent for the first curve is minus 1 by 2. So we know M1 and M2, therefore angle between the two curves using the formula we have determined. We have to determine using the formula angle between the two curves is angle between the two curves tan theta equal to modulus of M1 minus M2 by 1 plus M1 into M2. That is equal to what is M1 minus 1 by modulus of minus 1 by 2 minus M2 is 1. M1 is minus 1 by 2, M2 is 1 by 1 plus M1 is minus 1 by 2 into M2 is 1. So that is equal to minus of minus, minus 2, minus 3 by 2, minus 2 into minus 1, minus 2, minus 1 is minus 1 by 2, minus 1 LCM 2, minus 3 by 2 by 1 minus half into 1 is half, 1 minus half. So that is equal to mod of minus 3 by 2 by 1 minus half is 1 by 2. 2 to cancel, minus 3 modulus of value is 3. This is denominator 2 and numerator 2 are cancelled. These two cancel. Minus 3 by 1 is minus 3. Modulus value is 3. So finally, tan theta equal to, what is that? Tan theta, final step. Tan theta equal to mod of minus 3, because 2 cancel. Mod of minus 3 is 3. Tan theta equal to 3. Theta equal to tan inverse of, this is the angle between, acute angle between the two curves. Theta equal to tan inverse of 3. That is the answer for the problem. So theta equal to tan inverse 3 is the angle between the two curves. That's all about the problem. Angle between the two curves is tan inverse 3. Next, one more problem I am going to solve, that is given in your textbook is one more problem. Show that the curves x square minus y square equal to r square, xy equal to c square, where c and r are constant, cut orthogonally. The two curves are given. Tenth problem in the exercise. There are two curves, x square minus y square equal to r square. This is curve 1. xy equal to c square. This is curve 2. X square minus y square equal to r square. Xy equal to c square, where c and r are constant. C and r are constant. Given. Show that these two curves cut orthogonally. That means you have to prove that the product of the slope is minus 1. If the two curves are perpendicular or cut orthogonal, I already told you the product of the slopes m1 into m2 is minus 1. Since the two curves cut orthogonally, we have to prove that if the two curves cut orthogonally, we know that we have to prove that the product of the slopes m1 into m2 equal to minus 1. This is what we have to prove. Let the point of intersection of the two curves we will consider by x1, y1. And we will prove that the two curves cut orthogonally at the point of intersection. Let x1, y1 be the point of intersection of the two curves. Point of intersection of the curves 1 and 2. Let x1, y1, let the point x1, y1 be the point of intersection of the curves 1 and 2. First I am going to prove that the slope of curve 1 from 1, x square derivative is 2x minus y square derivative is 2y into derivative of y is dy by dx. X square is 2x, y square is 2y, derivative of y is dy by dx equal to derivative of r square is 0 because r is a constant. 2 cancel, you will get, you bring the y dy by dx that side, you will get x only in this side. 2 cancel, x equal to y dy by dx. X equal to, taking 2y dy by dx, that side 2 cancel. So dy by dx equal to x by y. Therefore dy by dx equal to, what do you get? X by y. You bring this y this side. dy by dx equal to x by y. Okay. Now dy by dx at x1, y1. At the point of one intersection is x1, y1. Therefore, we want dy by dx at the point x1, y1 is equal to x for x1, y for y1. This is your m1. This is m1. Next, slope of curve 2. From the curve 2, xy equal to c square, or differentiating x into derivative of y is dy by dx. plus y into derivative of x is 1 equal to derivative of c square is 0 because differentiation of the constant is 0 because c is constant, derivative of constant is 0. So x dy by dx equal to minus y. So dy by dx equal to minus y by x. So we want dy by dx at x1 y1, that is equal to minus y1 by x1. This is very important. So m1 is x1 by y1, m2 is minus y1 by x1. Therefore, product of their slopes. Therefore, m1 into m2 equal to m1 is x1 by y1 into m2 is minus y1 by x1. Okay, cancelling y1, y1, x1, x1 cancel, you get minus 1. x1, x1 cancel, y1, y1 cancel, you get minus 1. Therefore, m1 into m2 equal to minus 1. That's what we have to put. m1 into m2 equal to minus 1. So we derive that since the product of the slope is minus 1, therefore the two curves cut orthogonally. The two curves cut orthogonally. That's all about the problem. Oh, okay. So take down the problem. That's all about angle between the two curves. And we will continue the remaining exercise in the next video. Thank you.